Hey, man, we got a Yamaha drive-in. Been a minute since we did one, but we get one every once in a while. Don't run. We're going to do some tests, and at the end of this, you'll know what's wrong with it. Next thing we're going to do is make sure the toe switch is in the run position. Next thing you want to do is make sure you have it in the run position because it's probably sat there 3 or 4 months during the winter time not being used in the toe position. Now, if you need to look at the batteries are wired in the series, positive, negative, positive, negative. This one don't run, so let's do some tests. All right, so the story behind this golf cart is it come in, the batteries were dead. And I recommend anybody to do this. If you have any cart come in that's dead for a customer, or if your cart's dead, before anybody puts in a set of $1,000 to $1,500 set of batteries, get you the jumper cable, jump it off another cart to make sure that's the only problem. All right, let's get to it, man. First thing you do is always put your voltmeter on volts DC. That's V with a straight line, and we're doing 200 because it's over 20 volts. First thing we're going to do is put the black lead on the main negative and the red lead on the solenoid. We're going to put the red lead of your meter on the battery side of the solenoid. So that's the side that goes toward the battery pack, not the side that goes near the controller. And then the black lead, like I said, will go on B negative on the controller. And you can see by us touching the hot on the solenoid, we got 50.7 volts. All right. Now, don't assume you have battery voltage. What we're going to do is hit the gas. Jason, hit the gas. All right, he's hitting the gas. Voltage is not dropping down from 50.8 to 50.7. So the battery pack is definitely not a problem. So now we're going to the next step. Now the solenoid is clicking in, so the solenoid is engaging. So now what we're going to do is actually test the other side of the solenoid that goes to the controller to see if the solenoid is good. Because the voltage should be within 0.5 to 1 volt difference on both sides of the solenoid. So now what we're going to do is test the solenoid. We're going to take the black lead of your meter and put it on the small post on the black side of the solenoid, red lead on the red wire on the solenoid. Checking to see if we have battery voltage, which we know we do because the solenoid engaged earlier. But you can see hitting the gas, we have 49.7 volts. All right. Now we're going to check the other side of the solenoid to see if voltage is carrying over from the battery pack side to across. Just because the solenoid engages does not mean the solenoid is good. I've seen them inside where the contact burns out and then the solenoid is bad, but it clicks. Because the way it works, the two small posts have to have a hot in the ground to activate the solenoid. And then once the solenoid activated, it allows voltage to carry across the two big posts here. So you can see we got a black and a red on the small posts and two big posts. So when the black and red get a hot in the ground, voltage should carry from the right side of the solenoid to the left side of the solenoid. All right, the next test is, so far with the test we've done already, we eliminated 3 components. We eliminated first the key switch, because if the key switch didn't work, you wouldn't get a hot to the solenoid when you hit the gas. You eliminated the accelerator pedal micro switch because when you hit the gas it clicked, and you eliminated the toe switch because you have power because the solenoid clicked. Also, on the gas pedal, you eliminated that the potentiometer side was not stuck down, but it could still be bad, but just stuck closed. But also, man, when I say the potentiometer is good, I mean that the potentiometer is not stuck open, causing a high pedal disable. It's stuck, meaning that it's reading good. It's not bad like that. It still could be bad and not read the right voltage or the ohms, but as of right now, it's not stuck down. So the next thing we're going to do, but let me say this though, about 80% of the time, if the solenoid engages on these IQ systems, anything with a toe switch, the controller is good, because most of the time when the controller is bad, the solenoid is not engaged. So I would have to say motor if I had a choice. So now what we're going to do is test B negative on the controller, which is a wire straight from the motor. The white wire there is M negative. So we're going to test B negative and B plus to make sure we're getting voltage from the solenoid. And you can see when we hit the gas, voltage 50.6 volts. So now what happens is when he hits the gas, voltage goes from B negative to M negative. All right. So now we're going to put the red lead on B plus, the white lead on M negative on the controller, or A1. All right. So right now we're going to hit the gas. So now what we're going to do is test the output from the controller. We're going to put the black lead on A1, which is the output ground to the motor, and then we're going to put the red lead on B plus on the controller, which is the input from your solenoid. Because the way it works is when you hit the gas, voltage travels across the solenoid to the controller, leaves B plus on the controller straight to your motor, and then it gives it a ground. It fluctuates in voltage up or down depending on how far you hit the gas, which is how much voltage it puts out. All right. So you hit the gas and you're putting out 45 volts on the ground side. You're running good speed. You're putting out 41. You're running slow. All right. So let's test it and let's see what it does. All right, hit the gas. All right, he's hitting the gas. He's getting 9 volts out. So the controller is putting out something. So that right there tells me that the controller is putting out voltage. And let's try it again to make sure. All right, hit the gas. All right, he's hitting the gas again. You've seen 31 pop up, 4 volts, 2 volts. So the motor controller is putting out something. So what it's doing is there's something wrong with the motor and it's putting voltage out, but it's shutting down. So that right there tells me that there's something wrong with the motor. So what I'm gonna do is take the motor off. More than likely probably brush is stuck because the solenoid is holding when it engages. If the solenoid clicks in, clicks out real fast, then I would say controller. But with the solenoid clicking and holding, it's gonna be brushes stuck in the motor. So what I'm gonna do, man, I'll post a video later on about the motor, about taking it off, about like every other motor. But I'm going to keep going though. So now that we know that the motor is bad on this, while I got this here, because it's very rare we get Yamahas, I'm gonna show you how to test stuff. All right, so now we're going to test pin 5, pin 6, and pin 7, which is going to be to your throttle position sensor. All right, so now we're going to test the throttle position sensor. We're going to unplug the main harness. There's a small clip on top of the harness you push down, and it opens up the back of the harness and pulls off. So you want to take it, push down on it, and pull. If it don't do it, just reach back up there and pull down again. Push it again, and releases like that. All right, so now what we're going to do is we're going to test pin 5 and pin 7. All right, pin 6 just feeds voltage out to the throttle position sensor. But right now, we just want to test the ohms coming back from the throttle position sensor. So what we're going to do is pop this cap off first. That way you can make sure you have a good connection. Or if you got a set of ends on your voltmeter to stick in there, you can put them in there. You're going to pop this side off, but make sure once you get the cap off that you don't touch either side, any 2 pins together in there with your voltmeter, because you could fry something if you feed the wrong voltage. So what we're going to do is stick our voltmeter inside of pin 5 and pin 7, and you have to put your meter on 20K ohms. All right, that's 20K ohms. So we're changing the meter. But what we're going to do is test it. We're going to stick the voltmeter on the other end of the plug. Right now, I'm just showing you what wire is what. All right. So we're going to put the black lead of the meter onto pin 7. And then we're going to hit the gas and see what it shows. All right. Then we're going to put the red lead of the meter on pin 5 and see what it shows. All right. So let's see what we got here. And main thing, make sure you don't touch 2 pins together for safety because you'll burn something up. So we're going to put the red lead on pin number 7. We got 1, 2, 3, 4, 5, 6, 7. All right. And then we're going to put the black lead on 5, which is 2 away to the right of the red. And then we're going to hit the gas and see what the voltage shows. The voltage shouldn't show under 1.2 at the most without hitting the gas. All right. Now hit the gas. All right, Jason, hit the gas again, buddy. No, it's not going to run over nobody. I have it unplugged. All right, hit the gas. There you go. All right, you can see it went from 1.25 down to 0. Then we'll put my little black lead back in. All right, so right now we're at full throttle. All right, now he let go of the gas. So right there you're seeing the fluctuation that you want to see in the throttle position sensor. He's barely hitting the gas now, barely hitting it. He's getting longer, faster and faster to the floor. All right, now look, this is without hitting the gas, and this is while you hit the gas. And you can see So what you don't want to see, man, is you don't want to see a 0.4, 0.6, 0.7 without hitting the gas, because that's going to throw up the high pedal disable code. The car is going to shut down for safety, and then it's not going to run. It's not going to engage the solenoid. It's not going to do nothing. All right. So if it engages the solenoid, you know right then that you eliminated the throttle position switch and the toe switch and the key switch. All right. So right now I'm going to put this water boot back on. This protects it from the environments, the water, from getting in your plug, shorten the plug out. Now what I'm going to do is plug it back in, and then I'm going to try something. All right, make sure when you plug it back in, it snaps. All right, Jay, hit the gas, man. Maybe we get lucky. Maybe it's a connection problem. Nope, solenoid clicks, it don't run. All right, man, so at least sometimes, man, it might be a connection. Now, if you plug it back in and the car runs, it could either be a connection problem in the harness plug, or it could just be you had to reset the controller. Now, will it fix it permanently if that happened? No. That means something's probably the capacitors inside the controller is not storing good. But what I'm going to do, man, I'm going to post a video on this later on how to check the motor, man. Stay tuned, man. Appreciate it.